Imagine a place where the very fabric of reality frays and twists beyond recognition, a region so dense, so overwhelmingly powerful, that not even light can escape its grasp. This is the black hole, one of the universe's deepest enigmas, where the known laws of physics begin to unravel and our understanding of existence itself is challenged. But what truly lies inside these cosmic abysses? What do we encounter when we cross that invisible boundary known as the event horizon, the point of no return? For decades, black holes have been portrayed as these cosmic vacuum cleaners, relentlessly consuming everything in their path. Yet, recent discoveries suggest they are something far more complex, almost paradoxical. The event horizon doesn't just swallow matter, it marks a boundary where space and time exchange roles, where past, present, and future merge into an indistinguishable blur. To step beyond it is to step into a realm where the universe's deepest secrets flicker at the edge of perception. Scientists have long grappled with the challenge of peering beyond that veil. What lies inside a black hole remains inaccessible to direct observation, yet within its shadow, the laws governing reality crack open like glass. The immense gravity bends light and warps time until our familiar notions of cause and effect no longer apply. This cosmic enigma invites profound questions. Is the singularity at its core truly a point of infinite density, or a door to another dimension? Could black holes be bridges, or wormholes, to distant corners of the cosmos, or even gateways to entirely new universes? The implications are staggering. If black holes do not simply obliterate everything they consume, but somehow preserve or transform information, this could reshape our entire understanding of physics. Concepts like quantum mechanics and general relativity, once seen as fundamentally incompatible, might find a hidden harmony here, deep within the black hole's grip. Our journey into this mystery is more than an exploration of astrophysics. It is a quest to confront the limits of human knowledge and imagination. Each insight into black holes brings us closer to answering questions that have lingered since the dawn of scientific thought. How does the universe store and process information? What happens to time at the edge of a black hole? And ultimately, what can these cosmic shadows reveal about the very nature of reality? As we delve deeper, we must prepare to question everything we think we know. Inside these invisible maelstrom lies a story of paradox and wonder, a testament to nature's ability to surprise and confound. This is the unfolding mystery at the heart of black holes, an invitation to peer into the unknown and witness the extraordinary. What really happens inside a black hole? The answer may be stranger and more beautiful than anything we have yet imagined. To begin unraveling the enigma of black holes, it's essential to grasp the profound ways they challenge our understanding of space and time. Imagine spacetime not as a static, unchanging backdrop, but as a dynamic fabric, one that can stretch, bend, and warp under the influence of mass and energy. Black holes represent the most extreme distortions of this cosmic fabric, bending it so dramatically that familiar rules start to unravel. We often talk about gravity as a force pulling objects together, but in the vicinity of a black hole, gravity reveals itself as the curvature of spacetime itself, a curvature so extreme that it creates a one-way path, an event horizon beyond which escape becomes impossible. This boundless pull is more than a simple gravitational grip, it represents a fundamental shift in how we perceive the progression of cause and effect, or more poetically, the arrow of time. In the relatively gentle gravity we experience daily on Earth, time feels uniform, steady. But close to a black hole, time distorts, in fact, it dilates. From a distant observer's perspective, a clock falling toward the event horizon appears to slow down, almost freezing as it nears that boundary. Conversely, for anything unlucky enough to cross into the interior, time and space swap roles, and the future inexorably points deeper inward, toward the core. This strange interplay forces us to re-evaluate what time itself means when gravity rules so absolutely. Delving further inside, modern theoretical physics proposes that the boundary of a black hole, the event horizon, is far from being a mere passive border. Instead, it might serve as a kind of cosmic ledger, recording information about everything that has ever fallen in. This concept challenges decades of assumptions that information within a black hole is lost forever. Rather, the horizon could function like a vast, complex hologram, encoding the details of all matter and energy that crossed it. Such an idea hints at a remarkable connection between gravity, quantum theory, and thermodynamics, suggesting that the event horizon possesses entropy and even temperature, a surprising recognition that black holes are not simple, inert voids, but dynamic, physical entities possessing their own subtle thermodynamic life. Another layer unfolds when we consider the nature of the black hole's interior, a realm notoriously difficult to comprehend because, by definition, we cannot observe it directly. The equations of general relativity predict a point of infinite density and curvature, but this notion likely signals a breakdown of the theory itself, a call for deeper, more fundamental physics. Emerging frameworks, such as quantum gravity and string theory, begin to supply possible perspectives, suggesting that what lies inside may be a universe of quantum foam, a seething quantum landscape where spacetime itself loses its ordinary meaning. In these speculative models, spacetime becomes granular, discrete, subject to probabilistic rules far removed from everyday intuition. One concept arising from such theories is the idea of black hole complementarity, which proposes that the paradoxes associated with the event horizon may dissolve when viewed from different vantage points. To an external observer, information seems to hover at the horizon, smeared onto its surface. To an infalling observer, however, passage through the horizon feels uneventful, at least initially, with no obvious sign that reality itself is in flux. This duality, if true, forces us to confront a fundamental lesson of black holes, that reality may not be universal, but observer-dependent, with different truths revealed depending on one's frame of reference. The enigmatic borders of black holes also inspire deep philosophical and practical questions. If information is preserved somehow, even within these cosmic prisons, what does that imply for the fate of the universe's content over cosmic timescales? Could black holes play a role not just in cosmic destruction but also in cosmic recycling, contributing to a grander cycle of matter, energy, and information? Moreover, this intimate relationship between gravity, quantum phenomena, and information theory invites us to reconsider the nature of space itself as emergent rather than fundamental, perhaps an intricate byproduct of deeper, unknown quantum processes. Indeed, black holes stand as crucibles for new physics, laboratories not on Earth but scattered across the universe, where nature pushes toward extremes unattainable in human experiments. By studying them through telescopic observations, gravitational wave detectors, and theoretical inquiry, we gain a rare glimpse into regimes where the familiar laws dissolve and stranger principles emerge. The event horizon shines as a glowing beacon in this darkness, an arena where particles and radiation swirl before ultimate capture or transformation, and where relics of the past may linger encoded in subtle quantum whispers. As we refine our observations, capturing images of black holes' shadowed silhouettes or tracing echoes of colliding giants, the foundational background of these cosmic enigmas evolves. No longer merely objects to be feared or dismissed as cosmic voids, black holes beckon as profound teachers, beckoning us to expand our concepts of reality, challenge our most deeply held convictions, and embrace the unknown with a spirit of curiosity and wonder. They remind us that the universe is far stranger and more intricate than our everyday experience, and that at the intersection of gravity and quantum realms, a new chapter in our cosmic story begins to unfold. In the heart of every black hole lies a mystery so profound that it challenges the very fabric of our understanding, a place where the familiar contours of space and time seem to warp into something unrecognizable. The main theoretical framework scientists use to unravel this enigma is centered on what is often referred to as the black hole's interior structure, a realm far beyond the event horizon, where gravity's pull becomes so overwhelmingly intense that all known laws teeter on the edge of collapse. Traditionally, classical general relativity paints the black hole interior as a singularity, a point of infinite density and zero volume where everything that crosses the event horizon is inevitably drawn. This singularity represents not just a physical endpoint, but a conceptual abyss where physics, as it stands, fails to provide meaningful answers. It is an ultimate boundary of known science, a place where spacetime curves infinitely inward, and time itself appears to come to a halt. Yet, this seems anything but satisfying because nature abhors infinities. They signal a breakdown in our theories, suggesting new physics must emerge to explain what truly happens. In the quest for that new physics, the main theory emerging at the forefront involves a merging of quantum mechanics with gravity, an arena where the classical picture of the singularity might be replaced by something far richer and more complex. One such perspective envisions the black hole not as a region collapsing inward to a single point but as a dynamic quantum object with an intricate internal structure. Instead of an infinitely dense core, the black hole's inside might comprise a network of highly entangled quantum states, a seething, frothy quantum geometry fluctuating at microscopic scales. This shift in thinking arises from the attempt to resolve a paradox that sits at the heart of black hole physics, the so-called information paradox. If the contents of everything swallowed by a black hole were truly lost beyond the event horizon, destroyed by the singularity, this would violate one of the bedrock principles of quantum theory: information must be conserved. To preserve this, the holographic principle proposes that the three-dimensional information about all matter that falls in could be encoded on the two-dimensional surface of the event horizon itself, much like a hologram contains a full image in each fragment of its surface. From this vantage point, the interior of the black hole is not an empty pit but an emergent feature arising from the quantum information stored on the horizon. The interplay between this surface-bound information and the interior space unfolds in ways that challenge our intuition. It suggests the inside is not a separate enclosed realm but a shadow, a quantum projection of deeper, more fundamental data. This idea dramatically redefines what it means to enter a black hole. Crossing the event horizon no longer signals an irreversible plunge into oblivion but a transition where the classical description of space and time dissolves and is replaced by quantum informational processes. Delving deeper, some proposals suggest the interior may be akin to a kind of cosmic labyrinth, where quantum fields and particles exist in ever-changing configurations, interconnected through entanglement and quantum correlations extending across the black hole region. These interconnections could, hypothetically, form a bridge, a wormhole-like passage, between the black hole's interior and other regions of the universe or even to alternate universes. While this remains speculative, the idea has been bolstered by the discovery of surprisingly deep connections between entanglement in quantum theory and the geometric fabric of spacetime. Another compelling perspective emerges when we consider the fate of matter and energy as it falls inward. Instead of being instantaneously destroyed at a central point, incoming material could be smeared out by quantum gravitational effects, dispersing over the interior volume in a high-energy state sometimes conceptualized as a quantum star or fuzzball. In these views, the classical horizon is replaced by a fuzzy, dynamic surface where quantum processes prevent the formation of a sharp boundary and singularity. Matter and information become thoroughly mixed within this quantum structure, preserving their fundamental properties even as the black hole radiates energy through subtle quantum mechanisms. Implications for the flow of time within these domains are equally profound. The classical picture describes time grinding to a halt at the event horizon for an outside observer, while an infalling observer experiences a seamless passage toward the core. If quantum effects dominate inside, however, time itself may become an emergent phenomenon, relational and nonlinear, in such a way that the conventional cause-and-effect order we take for granted becomes blurred or altered. This suggests an interior realm not confined by normal temporal progression, where past, present, and future might intertwine in novel patterns dictated by quantum gravitational rules. The mysteries of the black hole interior also extend to the cosmological scale. Some hypotheses portray black hole cores as potential seeds for new universes, where the collapsing material inside does not end in destruction but instead bounces back, initiating a Big Bang-like expansion into another branch of reality. While such an idea remains speculative, it expresses a remarkable possibility. Black holes could be cosmic wombs, gateways to new realms of existence that continue the cycle of creation and evolution beyond the confines of our observable universe. In striving to understand what truly happens inside a black hole, scientists are thus drawn into a realm where geometry, quantum fields, and information intertwine. Each new insight challenges the boundaries between physics and philosophy, testing our notions of identity, locality, and the ultimate fate of matter. They invite us to imagine a universe more interconnected than ever before, where the innermost dark heart of a black hole is less a void than a crucible shaping the evolution of reality itself. As future technologies advance, including the refinement of gravitational wave astronomy and novel particle detectors sensitive to quantum gravitational effects, we may slowly begin to peel back the veil on these cosmic interiors. Until then, the main theory stands as a tantalizing bridge, a guidepost leading us toward a deeper understanding, one that may ultimately reveal that the black hole's mysterious core is not an end, but a beginning. Beyond the theoretical contours and the whisper of equations lies a profound truth. Black holes are not merely cosmic curiosities, but key laboratories for testing the fundamental laws of nature under conditions unreachable by any earthly experiment. By venturing further into the scientific expansion of black hole research, we uncover subtle clues etched in the fabric of spacetime itself, signatures imprinted by the extreme gravity on matter, energy, and information. These clues emerge most vividly from the event horizon, the boundary where gravity overwhelms even light, sealing the black hole's interior from the outside world. Yet, this boundary is not just a point of no return, but also a dynamic canvas where quantum effects weave a rich tapestry of phenomena that challenge classical intuition. One of the most intriguing scientific advances arises from the study of Hawking radiation, a theoretical prediction that black holes emit a faint glow of particles due to quantum effects near the event horizon. This radiation implies that black holes are not eternal prisons but slowly evaporate over immense timescales. The birth of Hawking radiation brought to light a deeper conundrum known as the information paradox. If information about matter falling in cannot escape, yet the black hole eventually evaporates, where does that information go? Understanding this paradox has driven physicists toward the precipice of a unified theory, where gravity and quantum mechanics can coexist without contradiction. Recent developments suggest that information might be preserved on the event horizon itself, encoded holographically in 2 dimensions, an astounding idea that space, time, and locality may be emergent rather than fundamental, reframing the black hole's surface as a richly informative entity rather than an inscrutable veil. Further observational insights are gleaned from the new era of gravitational wave astronomy. When massive black holes collide, the ripples they send through spacetime reveal not only their masses and spins but potentially the intricate structure of the horizons and interior geometry. These gravitational echoes offer unprecedented opportunities to test deviations from classical general relativity, seek signs of proposed quantum structures, or even glimpse novel states of matter compressed into unimaginable densities. For example, hypothetical exotic objects called gravastars or fuzzballs have been proposed to replace the classical notion of a singularity, combining principles from string theory and quantum gravity. Detecting subtle differences in the echoes could lend credence to these ideas, rewriting the story of collapse and destruction inside black holes into one of rich quantum complexity. Moreover, the physics inside a black hole's horizon beckons a re-evaluation of time itself. To an external observer, infalling matter appears to freeze and fade at the event horizon, dragged ever closer to an eternal moment. However, for the matter itself, proper time contracts, and the journey ends abruptly at the singularity, or so classical theory predicts. Here, quantum gravity may provide alternatives, smoothing out the singularity into a finite, possibly bouncing state, thereby circumventing infinities and causal anomalies. Such mechanisms could instantiate a radically different temporal landscape within black holes, where time loops, branches, or transitions into other dimensions may unfold. This not only transforms how we interpret singularities, but challenges our understanding of the arrow of time, the unidirectional flow that defines our experience, and hints at a more nuanced, often hidden temporal architecture threading the cosmos. Another vital frontier concerns the role of entropy and thermodynamics at black holes. The realization that the event horizon's area corresponds to entropy, as encapsulated in the Beakenstein-Hawking formula, bridges gravity, quantum theory, and thermodynamics in a way that hints at a microscopic description of spacetime itself. If spacetime is ultimately discrete, composed of fundamental quanta akin to atoms of space, then black holes become crystalline laboratories revealing their statistical underpinnings. Advances in loop quantum gravity and string theory attempt to count these fundamental states, yielding insight into the nature of quantum geometry. This endeavor promises not only to elucidate black hole microstates but to uncover the quantum structure of our universe at its most elemental level. The interplay between black holes and the quantum vacuum also offers fertile ground for speculation and discovery. The vacuum is not an empty void but teems with fluctuations of virtual particles and fields. Near the event horizon, these fluctuations become tangible, seeding entangled particle pairs that influence Hawking radiation and potentially mediate information transfer. This phenomenon hints at a profound connectivity. Black holes are interlaced with the quantum fields permeating space, suggesting that the vacuum itself might play an active role in the evolution of these gravitational maelstrom. This could provide a natural laboratory for unifying quantum field theory with gravitation, currently one of the most daunting challenges in physics. Astrophysical observations add further texture to our understanding. The recent images of black hole shadows captured by the Event Horizon Telescope showcase the intense environment at the precipice of these enigmatic objects, revealing swirling accretion disks and powerful jets propelled by magnetic fields twisting against the backdrop of warped spacetime. These phenomena underscore that black holes are not isolated voids but dynamic engines shaping galaxies and the cosmos itself. The interaction of black holes with their surroundings feeds back into their growth, spin dynamics, and possibly the subtle quantum states tied to their horizons. In this energetic dance, even the violent processes of matter destruction may play a role in quantum information preservation, encoded in patterns yet to be decoded. Across all these lines of inquiry, a compelling narrative emerges. Black holes serve as bridges between the very large and the unimaginably small, between the smooth fabric of spacetime and the jittery world of quantum phenomena. They compel us to reconsider long-standing concepts such as locality, causality, and the nature of reality itself. As one delves deeper, it becomes apparent that black holes do not merely conceal secrets but actively challenge the pillars of modern physics, inviting a synthesis that could redefine how humanity perceives existence. As our observational tools sharpen and theoretical frameworks evolve, we edge closer to reconciling these seemingly paradoxical realms. The scientific journey inside a black hole is thus not a descent into darkness, but an ascent toward new horizons of understanding where the heart of mystery pulses with the promise of revelation, and where each question answered uncovers a deeper layer of cosmic wonder. In this unfolding story, the black hole is not a finality, but a profound challenge, compelling us to expand the boundaries of knowledge and imagination, forever reaching toward the unknown. Beyond the mathematical elegance and physical rigor, black holes beckon us toward deeper philosophical contemplation, inviting us to grapple with questions about consciousness, reality, and the very meaning of existence. When we think of a black hole, what initially emerges is the image of an overwhelming, inescapable void, an abyss where light, time, and even certainty seem to dissolve.
Yet, this seeming finality raises a paradox that extends far beyond physics and into the realm of human understanding. What does it mean for something to exist if it eludes all possibilities of observation and interaction? Philosophers have long wrestled with the concept of reality as inherently tied to perception. If a black hole's core, the singularity, is forever beyond reach, existing in a domain where conventional spacetime breaks down, can it be said to exist in the orthodox sense? Or does it compel us to reconsider existence itself as layered, potentially including realms or states beyond human cognition? Here lies a striking analogy with consciousness. Like the event horizon that borders the unknown interior of a black hole, our awareness may have its own boundaries, phenomenal horizons beyond which the mind cannot venture, yet behind which something essential might reside. In contemplating black holes, we confront an ontological challenge. They are simultaneously entities defined by the extreme limits of knowledge, and paradoxically, by their profound inscrutability. They exist on the edge where meaning blurs, a liminal space that destabilizes simple definitions of cause and effect, presence and absence, life and annihilation. This invites a radical philosophical inquiry. Does the universe hold intrinsic meaning independent of observers, or does meaning arise only as an emergent property of interaction? Black holes, in their inscrutable depths, seem almost like cosmic mirrors reflecting the human condition, the tension between certainty and mystery, presence and loss, understanding and the endless quest beyond it. Moreover, black holes press us to reimagine time itself, not merely as a linear progression marching forward, but as something malleable, even subjective. Inside the event horizon, time may cease to behave in ways coherent to us, it can stretch, contract, or perhaps fold upon itself. This disruption of temporality loosens our grip on causality, the very thread weaving the fabric of experience and consciousness. If time unmakes itself, how then do we anchor meaning in a universe where beginnings and endings intertwine? Could black holes hold the key not only to reconciling gravity and quantum mechanics, but also to unlocking a deeper understanding of temporality and existence that transcends human perception? This line of reflection naturally extends to cosmology itself. Some theoretical frameworks speculate that what we perceive as a black hole's singularity could correspond to a new genesis, a seed from which an entire universe might emerge. If so, each black hole might be not so much a tomb of matter and information, but the womb of creative potential. Such speculation transforms black holes from cosmic graveyards into crucibles of birth and possibility, reshaping the ultimate narrative of existence from an arc of decay into one of continuous becoming. This is not merely poetic musing, but an invitation to see cosmic processes as cyclical and regenerative, resonating philosophically with ancient and modern worldviews alike. Turning inward, this awareness challenges how we conceive of our place in the cosmos. If black holes embody both ultimate destruction and possible creation, they force a reconciliation between despair and hope, between the finitude of life and the vastness of cosmic cycles. Their mysteries provoke humility, reminding us that our current frameworks, scientific, philosophical, existential, are provisional and incomplete. Yet, in embracing uncertainty, black holes ignite wonder and curiosity. In the face of the unknowable, they become catalysts for growth, driving the human spirit to expand its horizons of imagination and understanding. At the same time, black holes confront us with the delicate interplay between absence and presence. Their shadows on spacetime reveal the profound significance of nothingness, a concept imbued with paradox, as it is neither emptiness nor simple void but a dynamic, restless state pregnant with possibility. This challenges classical metaphysics and invites contemplations akin to those found in mystical traditions, where the void is not a place of negation but a source of all potential. Of course, framing black holes in such terms does not diminish scientific rigor, instead, it enriches the dialogue between empirical knowledge and metaphysical meaning. Finally, Contemplating black holes invites us to reflect on consciousness itself as a phenomenon intertwined with the cosmos.
Modern debates in philosophy of mind and physics speculate whether consciousness might somehow be fundamental, not merely arising from matter but interwoven with physical laws at the deepest levels.
If reality near and inside black holes defies conventional explanation, might consciousness too have undiscovered facets linked to such extreme environments? While speculative, this opens profound questions. Could our own awareness be part of a larger, interconnected fabric, stretching across cosmic scales and dimensions? Might black holes, enigmatic and silent, hold clues not only about external realities but about the inner landscapes of mind and being?
In the end, the philosophical depth of black holes lies less in definitive answers and more in the questions they compel us to ask, questions about boundaries, transformation, and the limits of knowing. Their mysteries invite us to hold space for paradox, to embrace the tension between the finite and the infinite, between what is revealed and what remains forever concealed. In doing so, black holes become not just cosmic phenomena to be studied, but profound symbols for the human quest, a journey toward meaning in the vast, unfolding tapestry of existence. As we venture deeper into the shadowy recesses of black holes, the unsettling possibility arises that these cosmic entities are not merely the endpoints of matter and light, but portals to realms where the familiar laws of physics unravel into something altogether stranger. Imagine a place where time itself begins to fray, a domain where cause and effect might lose their meaning, and where the flow of events is swallowed by an abyss of singular uncertainty.
One such notion emerges from the puzzles that confront physicists when trying to reconcile quantum mechanics with gravity. The classical view of a black hole's core, the singularity, has long been portrayed as a point of infinite density, where matter collapses under its own weight to vanishing volume. But infinity is a concept that signals the breakdown of our theories, a mathematical red flag that demands re-evaluation. What if, instead of a singularity, the heart of a black hole conceals a more intricate, perhaps even more bewildering, structure?
Some modern proposals suggest the singularity might be replaced by a complex, quantum gravitational state, a tangled web of space and time fused at the smallest scales, a quantum fuzz that defies any classical description.
This leads to striking possibilities. Could black holes be cosmic archives of the universe's deepest secrets?
It is hypothesized that instead of destroying information outright, a paradox that has long troubled physicists, black holes may encode the details of everything they engulf within their event horizons, preserving a shadowy imprint in a form we have yet to comprehend. This subtle ledger of information might mean that black holes are not the ultimate erasers of history but rather enigmatic libraries, hidden behind the veil of gravity's fiercest grip. The mind reels imagining a cosmos where what falls in may, in some mysterious manner, influence what later emerges. The phenomenon known as Hawking radiation hints at this tantalizing thread whereby black holes emit faint, ghostly streams of particles, slowly evaporating over unimaginable timescales.
This radiation might carry with it whispers of the black hole's interior, encoded in subtle correlations, suggesting that the boundaries of black holes are far from impermeable. Instead, these horizons could act as complex membranes, dynamic, fluctuating surfaces where the interplay of quantum phenomena and gravity choreographs an exquisite dance we are only beginning to discern. Even more unsettling is the notion that black holes might connect different regions of spacetime through tunnels called wormholes. While purely speculative, these theoretical passages could create shortcuts through the cosmic fabric, linking distant points or even parallel universes. If true, this offers a profoundly radical rethinking of black holes, not as endings, but as gateways.
A wormhole would transform a black hole from a cosmic trap into a potential conduit for exploration beyond our current horizons. While we have no direct evidence for such traversable portals, the mathematics keeping these possibilities alive suggest that black holes might harbor hidden connectivity, a secret topology of the universe folded into their essence. Furthermore, the very nature of the event horizon, the shimmering boundary that separates the known from the unknowable, challenges our grasp on reality. Far from a neat curtain, some theories propose the horizon acts as a seething, holographic surface, with every bit of three-dimensional information reducible to this two-dimensional veil. This holographic principle, inspired by the striking parallels between black hole physics and quantum theory, hints at a revolutionary view: the universe itself could be a hologram, where the true depths of reality are encoded on distant, lower-dimensional boundaries. Black holes are, in this vision, the quintessential embodiment of such holography, their event horizons pulsing with encoded data that underlie the fabric of space and time itself. Taking a different path, some thinkers have pondered the unsettling idea that black holes might be cosmic seeds of new universes, engendering fresh spacetime bubbles in a vast multiverse. Within their depths, the crushing collapse and extreme energies could spark a rebirth, birthing new realms entirely detached from our own cosmos. If so, black holes are both tombs and cradles, destruction and creation intertwined in a cosmic phoenix cycle. This gestation of universes beyond the veil stretches our imagination to dizzying heights, suggesting that the end of one cosmic story might be the beginning of countless others, hidden from our view but alive in the grand continuum. The profound mystery of black holes also touches on the ultimate nature of reality itself. If the classical image of a black hole as an inescapable pit of doom fails to capture the full picture, what does that say about the underpinnings of existence? Perhaps our conception of spacetime as a smooth, continuous stage is only an approximation, a shadow cast by deeper, discrete structures. In this light, black holes become laboratories for the quantum nature of space, where the fabric of reality is woven from fundamental atoms or threads, whose interactions give birth to the worlds we inhabit. Within these enigmatic realms, the familiar concepts of space and time might dissolve into a froth of probabilistic, interconnected possibilities, an arena where the boundaries between being and nothingness blur. One cannot help but consider the human place amid these cosmic enigmas. As black holes challenge our understanding, they beckon us to embrace humility and wonder. They nudge us toward an ever deeper inquiry, not just into the external universe, but into the assumptions and conceptual frameworks that underpin our knowledge. Here, at the limits of comprehension, black holes stand as stark reminders of what remains elusive: the fundamental nature of reality, the unity of forces, and the threads that bind existence in a coherent whole. In this dance of the unknown, black holes invite us not only to look outward but also inward, prompting an intimate reflection on the mysteries that shape our own experience of life and the cosmos. The dark possibilities they embody are not mere voids of ignorance, but wells of potential discovery, profound thresholds where new physics may emerge, where the cosmos reveals not just what it is, but what it might become. So the black hole remains a testament to the unknown. It is a symbol of nature's hidden depths and the limits of human knowing, a profound challenge to both science and imagination. Beyond the glowing accretion disks and the gravitational grip that traps light itself lies a frontier where the very essence of reality shimmers, an invitation to peer into the abyss, and perhaps, to glimpse the infinite possibilities poised just beyond the edge of darkness. As we conclude this journey into the clandestine heart of black holes, it is essential to appreciate their paradoxical nature, places where the known laws of physics dissolve into uncertainty, yet where the promise of understanding still beckons with irresistible force. These cosmic enigmas are not merely astronomical phenomena to be catalogued or mapped, they represent crucibles of transformation, laboratories of extreme conditions where space and time are stretched and contorted to their utmost limits. The singularity, if it exists as theorized, is not just a point of infinite density, but a gateway to questions that defy conventional wisdom. Could the fabric of reality itself be woven differently here? Could hidden dimensions or alternate realms reside behind the veil of the event horizon? The event horizon, often described as the point of no return, serves as more than a boundary. It is a dynamic interface between the familiar universe and an uncharted domain. Recent advances suggest it may be more of a shimmering membrane, an ever-fluctuating horizon where quantum effects ripple through the fabric of spacetime. This boundary challenges the classical separation between inside and outside, hinting at a profound interconnectedness that blurs lines once thought inviolable. Consider, too, the profound implication of information paradoxes that arise from black holes. If information is fundamentally conserved in the universe, yet cannot escape the clutches of the black hole, our understanding of causality and determinism is pushed to the brink. This paradox has propelled new theoretical frameworks, such as the holographic principle, which suggests that all the information contained within a volume of space can be represented on its boundary. Could the seemingly inscrutable depths of a black hole be encoded not in the obscured heart but on its luminous perimeter? This notion invites us to rethink our grasp of space itself, not as an empty void but as an active participant in the cosmic story. Moreover, black holes exert a profound influence on their cosmic neighborhoods, shaping the evolution of galaxies and the very structure of the universe. They are engines of creation as much as destruction, feeding on surrounding matter and spewing out energy that can trigger star formation or regulate the growth of galactic cores. In this way, black holes embody a cosmic duality, agents of both endings and beginnings, custodians of cosmic cycles that operate on timescales beyond human reckoning. From an epistemological perspective, black holes expose the limits of observation and the challenges inherent in probing phenomena that by their nature elude direct scrutiny. They force physicists to innovate, to imagine instruments and theories that stretch beyond traditional horizons. Yet, perhaps their greatest gift is to remind us that the pursuit of knowledge is an ever-evolving narrative, one not solely about accumulation but about transformation, how new questions arise from attempted answers, how perspectives shift as boundaries are pushed. In contemplating black holes, we are drawn into a dialogue balancing awe and precision, mystery and clarity. They challenge the arrogance of certainty, inviting instead a reverence for complexity, and a humility before the cosmos' vast, enigmatic depths. We are reminded that while black holes consume everything that crosses their event horizon, they also illuminate the frontiers of human curiosity. They stand as silent teachers of the cosmos, revealing that the most profound truths often reside where light cannot reach. Ultimately, the allure of black holes lies in their role as cosmic catalysts, for science, for philosophy, and for imagination. They summon us to peer beyond the veil, to question, to dream. While we may never fully unravel their deepest secrets, the quest itself enriches our understanding of existence. In reaching toward the shadowed heart of a black hole, we find ourselves drawn into an endless odyssey, one that compels us to explore not only the universe around us but the very nature of reality itself. And so, as we turn our gaze back from the abyss, we carry with us a profound sense of wonder and a renewed appreciation for the mysteries that make the cosmos and our place within it so endlessly captivating. The black hole, enigmatic and inscrutable, remains a beacon inviting us ever onward, ever deeper, into the vast, unfolding story of the universe. Beyond the boundaries of the event horizon, the black hole's interior remains a realm not of darkness alone, but of staggering complexity, where our classical understanding of physics begins to fray. Imagine space and time not as fixed, unyielding backdrops, but as dynamic participants, stretched, twisted, and warped into forms that defy everyday intuition. Here, gravity is no longer a force acting at a distance, it is the very fabric of reality contorting into an exotic configuration. Consider the fabric beneath your feet, now imagine stretching it until the threads begin to tear and wrinkle in unfamiliar patterns. This is somewhat akin to what theorists envision happening inside a black hole. Space itself folds inward, funneling everything toward an elusive core. But unlike a simple pit or well, this region does not just trap objects, it reshapes the notions of space and time themselves. Within this realm, the coordinates we rely on to measure distance and duration invert and interchange, making the interior of a black hole an unknowable labyrinth not only spatially but temporally. One compelling analogy comes from the idea of a river flowing faster than its own waves can travel against it. Outside the event horizon, light and information can swim upstream, escaping or reaching the outside universe. But once past this point, the flow of spacetime becomes so swift inward that even light, the fastest traveler, can no longer resist the current. This river model illustrates how every path leads inexorably deeper, where no return is possible. Recent advances suggest that the event horizon might not be the smooth cloak once imagined, but a turbulent, seething region. Quantum theory hints that this boundary is alive with fluctuations, virtual particles popping in and out of existence, blurring the once clear line between the black hole and the outside world. Some physicists propose that this quantum activity might encode the information of everything the black hole has ever consumed, preserving it in a delicate, holographic manner at the event horizon itself. This bold idea bridges the realms of quantum mechanics and gravity, suggesting a universe where information is never truly lost but transformed and stored at the boundary of darkness. Delving even deeper, the core or singularity, traditionally depicted as a point of infinite density, raises profound questions. Infinity in physics often signals the breakdown of theory rather than a physical reality. Modern perspectives entertain the idea that singularities may not be infinitely small dots but instead represent exotic states of matter or space, perhaps a new phase of reality governed by quantum gravity. String theory and loop quantum gravity, leading contenders for a unified physics, propose that the singularity could be replaced by a quantum foam or a tightly wound network of vibrating strings, whose incredibly small scale escapes direct observation but fundamentally shapes the black hole's heart. Beyond theoretical speculations, black holes might also have a cosmic duality we barely grasp. Some models suggest that what we see as a black hole from the outside could correspond to an entirely different region of spacetime when traversed internally, linking to alternate universes or distant parts of our own cosmos through hypothetical wormholes. These bridges, if they exist, might connect different points in space and time, opening perplexing vistas on the nature of reality and causality. Though purely speculative now, such ideas challenge the very fabric of linear time and spatial separation. Equally fascinating are the black holes' roles as natural laboratories for extreme physics. Conditions near their edges compress matter and energy to levels unattainable on Earth, enabling phenomena like relativistic jets, streams of particles accelerated to nearly light speed, that blast through galaxies. The mechanisms powering these jets invoke complex interactions between magnetic fields and spinning spacetime, hinting at the nuanced choreography between gravity and electromagnetism. Understanding these jets not only reveals the black hole's might but also sheds light on galaxy formation, starbirth, and the cosmic cycles of creation and destruction. Moreover, black holes compel us to rethink entropy, the measure of disorder and information content. The pioneering work of physicist Jacob Bekenstein showed that black holes possess entropy proportional not to their volume, but to the surface area of their event horizon. This startling insight links gravity, thermodynamics, and quantum theory, suggesting that the universe's deepest secrets may be encoded on two-dimensional surfaces rather than within volumes, a revolutionary concept now tied to the holographic principle. This principle insinuates that our three-dimensional world might itself be a projection of more fundamental information encoded elsewhere. The implications of these findings ripple beyond astrophysics, questioning our very definitions of space, time, and reality. Black holes serve as crucibles where classical and quantum worlds collide, presenting a frontier where future discoveries may unravel the enigmatic laws governing everything from the tiniest particles to the cosmos's grandest structures. They invite us to explore questions once considered purely philosophical: are space and time fundamental constituents of the universe, or emergent properties of deeper underlying entities?
Could understanding black holes lead to technologies that manipulate gravity and spacetime in ways currently unimaginable?
Yet, the black hole's greatest mystery might be that of perception itself. We can only infer its interior by tracing the behavior of light, matter, and gravitational waves from afar, like trying to understand an ocean's depths by watching ripples on its surface. Each new observation, from gravitational wave signals of merging black holes to the striking images captured by the Event Horizon Telescope, offers pieces of a vast cosmic puzzle, yet many essential elements remain out of reach, veiled behind horizons no light escapes. In embracing these enigmas, black holes encourage a humility and openness in science, that no matter how advanced our tools or theories become, nature may harbor secrets that stretch beyond human comprehension. Still, it is within this tension between the known and the unknowable that the beauty of black holes truly emerges. They are not merely destructive forces but profound storytellers, whose buried depths whisper tales of a universe far stranger and richer than our senses alone can reveal. So, in pondering the inscrutable interior of a black hole, we glimpse not just a cosmic oddity but a portal into the deepest questions of existence. What happens beyond the veil may forever elude direct experience, yet its echoes resonate through the fabric of space, time, and consciousness itself, reminding us that every journey into darkness is also a quest for illumination. In contemplating black holes, we inevitably confront the fragile boundaries between reality as we perceive it and a deeper reality that may lie beneath or beyond it. Our everyday experience of existence is constructed from the steady flow of moments, what we call time, and the consistency of space around us. We move, we see, we remember, and through these acts, we weave the tapestry of meaning. Yet, black holes challenge the very framework of this experience. They suggest that time is not an absolute river flowing uniformly everywhere, but a malleable dimension, distorted and stretched until its familiar rhythm ceases. What happens, then, to consciousness when faced with such a rupture in time itself? The prospect invites us to question whether our sense of self, our inner narrative, might be tethered not only to brain function but also to the fabric of spacetime that supports it. Imagine an observer falling into a black hole, though never outwardly perceivable to us, whose progression slows infinitely relative to distant observers, caught in a suspension between moments that unravel differently depending on vantage point. Does consciousness itself fracture or dissolve, or could it transform into something beyond our current understanding? Some philosophers and physicists today explore whether consciousness might interface with the universe at a fundamental level, influenced not just by physical neural processes but also by the underlying quantum and gravitational phenomena that govern all existence. If this is true, the encounter with a black hole might represent a radical stripping away of assumptions. The boundaries between subject and object, inner and outer, might blur or even vanish. This reflection extends beyond individual awareness to a collective human reckoning. Black holes, immense and impenetrable, embody a cosmic humility. They remind us that there are limits to what can be known or controlled, a paradox in an era dominated by technological advancement and empirical certainty. Our cultural narratives have long prized mastery and understanding as the pinnacle of human endeavor, yet here, in the very heart of the universe, lies a realm where certainty dissolves. This invites a reorientation, to embrace mystery not as ignorance to be overcome but as an essential element of the cosmos, fostering a sense of awe that can inspire creativity, compassion, and wonder. The unknowable within black holes becomes a mirror reflecting our own existential questions, the search for purpose, the encounter with the unknown, the acceptance of ambiguity. In a sense, black holes become a metaphor for the journey inward as well. Just as light, matter, and information seem trapped beyond the event horizon, so too might aspects of ourselves lie obscure or inaccessible, veiled within the depths of our own being. They call us to explore the boundaries within our minds and hearts, to recognize that like the universe they inhabit, human consciousness is vast and still largely uncharted.
The paradox of black holes, regions where known laws break down and novel phenomena emerge, echoes the inner paradoxes of identity and existence. The grappling with these enigmas can lead us toward a profound appreciation of our place in the cosmic order, a recognition that to navigate the darkness is to seek not annihilation but transformation. Moreover, the mysteries folded into black holes hint at a profound interconnectedness woven into the fabric of reality itself. Theoretical physics suggests that information is never truly lost, even in the domain where classical intuitions fail. This has profound implications for how we understand continuity and change, not just in physics but in life. Perhaps, then, disappearance does not imply oblivion. Perhaps within the deepest recesses of black holes, something endures, encoded in ways we are only beginning to glimpse. This challenges the notion of finality, suggesting instead that existence is a continuous narrative, where even death, decay, or collapse might serve as thresholds to new beginnings or transformations beyond our current horizon. As we peer into the abyss, our reflections reveal as much about ourselves as they do about the cosmos. Black holes urge us to reconsider what we mean by reality, to question the solidity of time, to rethink the nature of existence and awareness. They compel us to recognize that the universe is not a fixed stage but a dynamic, unfolding mystery, a story told in the silent language of gravity and light, of presence and absence, of being and becoming. And in this silent dialogue, we find a profound lesson, that to confront the unknown is to engage in the very essence of what it means to be alive, a quest that ultimately connects the human spirit to the cosmic dance, spiraling ever inward and outward, toward understanding and beyond.